All right, we need to start by distributing. On the left-hand side, 4 times x is 4x, and 4 times 3 is 12. So 4x plus 12 equals 1. Start to isolate the x, so subtract 12 from both sides. We end up with 4x equals negative 11. To remove the 4, we divide both sides by 4, leaving us with x equals either negative 11 fourths or negative 2.75. Okay, number 2, we simply need to get rid of negative 13 by adding 13 to both sides, leaving us with q equals 0. For number 3, divide both sides by 21. 3 divided by 21 is 1/7 when it's simplified. We do not want to round this decimal. That's a rational number. Keep it a reduced fraction. Okay, and number 4, now I'll do this one two ways. First, you could consider the 7/11ths all to be the coefficient, in which case you would multiply both sides by the reciprocal 11 over 7, which gives us 77 over 77, or 1, as our final answer. An alternate method would be to do this as 2 steps, where you first see that you're dividing both sides by 11. So if you multiply by 11 on both sides, the denominators are canceled and we get 7f equals 7. Therefore, when you divide by 7, you again get 1. Number 5, add 7 to both sides. So 7 plus 2/3 ends up being, that's 21/3 plus 2/3. 7 and 2/3 is actually 23/3. So 5q equals 23/3. We would divide both sides by 5. Now remember, to divide a fraction by an integer, that's really 23/3 divided by 5 over 1. You multiply by the reciprocal, so that becomes 23/3 times 1/5. Multiply numerators and multiply denominators. We're left with 23 over 15 as our value of q. In number 6, there's a negative sign in front of the parentheses, so we'll need to distribute that negative sign first. So that does not change the 8x. You would leave that alone. Get 8x minus 3x minus 2 equals 1. Combine the like terms. The 8x minus 3x is 5x minus 2 equals 1. Add 2 to both sides. We have 5x equal to 3. And to eliminate the 5, you divide both sides by 5, leaving either 3/5 or 0.6. Okay, starting with number 7, we're looking at a pattern of hexagons in which we're interested in the perimeter of each figure. So we need to get a count of the perimeter in each step. So step 1, the perimeter is 6. Step 2, it's not 12. When you count your way around, we're going to ignore the right side of the first hexagon and the left side of the next hexagon. Where they touch in the middle, you do not count that as part of the perimeter. Step 2 has a perimeter of 10, and step 3, the perimeter would be 14. So when you analyze your pattern, you're noticing that we add 4 to the perimeter in each step. Okay, so if we continue that, add 4 to 14, step 4 would have a perimeter of 18. Step 5 would have a perimeter of 22. And step 6, you'd be up to 26. So number 7 asking us for the total perimeter in steps 5 and 6. 5 again was 22. Step 6, 26. All right, and number 8, we need to write a rule so that we can predict the perimeter for any step, call it step n. Okay, so one way to do this would say I'm starting with the 6 that's in the first figure, plus I add 4 for each additional figure. So start with a 6, add 4 repeatedly. But how many times do you add 4? Well, not every step, but every step after the first. So we're going to multiply the positive 4 times n minus 1. N minus 1 representing the step number minus the first step, since we did not add 4 to get to our total in step 1. We started with the 6. Using that formula to get the total perimeter for step 25, that would make our n in our formula 25. So 25 minus 1 is 24. So 6 plus 4 times 24. Order of operations would tell us to multiply the 4 times 24, giving us 96. Add on the 6 from step 1, you have a perimeter of 102. Okay, number 10, there's a different formula, a different equation to stand for the same pattern. This time it starts with a 1. So I would think of that as the left side of the entire figure is the 1. It never changes, it never goes anywhere, it never gets covered. Okay. But then we would say we're going to add 5 sides for each figure. However, you would notice as some of the sides start to get covered, you don't add the full 5 every time. Or if we did add 5, we would need to subtract the sides that cover each other. Well, each time we add another figure, we're covering one less side than the step we're on. So when we're on step 2, we cover one side. When we're on step 3, we cover 2 sides. What I'm calling here the inner sides. So if we add 5 for every step, we then have to balance that by subtracting the inner sides that are not actually part of the perimeter. Okay, and then number 11 gives us still a third formula for the same pattern. This one says to start with 6n. Well, I think it's probably obvious that the 6 is because each hexagon has 6 sides. So if you started by saying, I would count all 6 sides for each hexagon. Well, because some of them are covered, you would then have to subtract some of those sides. They don't all count. So how many would you subtract? Well, each step after the first one, again, that's why we go back to n minus 1. We would not do this for the first step, but every step after the first one, you would have to subtract 2 of those sides.